Good afternoon, everyone. Today we'll continue with 11.3. We have done about that last time. We did one problem from there. Let me show you. Yeah, so on last Thursday, we did one problem from 11.3. Okay, and my assumption is that you already watched the lecture video up to the one I assigned you to watch today, which is today is the 17th. So I asked you to watch up to this one, right? Okay, up to this one. Okay, now you may want to watch the 19th also. Okay, this one and this one. Because today I will finish, I believe I will finish like basically after today we have only linear regression left. Only linear regression left. And linear regression will be seen on this lesson 23. Okay, yeah. Now my plan is this, that today we finish, let me go back. Yeah, today we will finish chapter 11. So on this Wednesday, we will do review for tests. For test 4. Okay, so this is on Monday. Today we do finish up chapter 11. And then Wednesday we do review for test 4, because next Wednesday we'll have test 4. Now, next Monday we will do linear regression, which will not be in test 4, but it will be in your final, only in your final. Okay. Now, after next Wednesday, which is you have test 2 weeks ago, right? That's week 12. Today's this week is week 14. Next week is week 15. So this is week 14. Next week is week 15. Now the week after that, you have final. Okay, now your final is on, let me check your syllabus. Your final will be on June the 7th. Yeah, your final will be on June the 7th. Your final will be June the 7th. Okay, let's put the date here. Today is the 17th, so next week is the 24th, right? Now, and then the week after that is May 31st, but that's a Memorial Day, no class. Now, that Wednesday of the final week, we don't have class, but I will hold my extra office hour. Okay, so that on the June the 2nd, I will have extra office hour. I may record me going over some old tests, all final. Okay, so I will go over old final. Now your final will be on Monday. So basically your final is supposed to be on the Memorial Day, but then it gets postponed for 1 week until the Monday after, 1 week after that. Okay, now the office hour there, again, this is a office hour in which I'm not required to hold all my office hour there, but I will do it so that we have one recording. I hope I can go over at least one old final. Okay, at least one old final from there. Okay, that's for the little review of what's gonna happen in the next 3 or something weeks. Okay, we will continue 11.3b, like hypothesis testing on two population means independent case. Okay, let's see. Now we have question number 9 from 11.3, from section 11.3. Do people walk faster in the airport when they are departing, getting on the plane, or when they are arriving, getting off a plane? So if it is getting on the plane and getting off the plane. Now, researcher Seth B. Young, I believe he is I think he's a statistician also. Measure the, I say that because I think there's somebody with that name writing a stats textbook. Well, anyway, measure the walking speed of travelers in San Francisco International Airport and Cleveland Hopkins International Airport. Now, his findings are summarized in the table here. Okay, the mean speed, and then standard deviation for departure, arrival, and sample size. Now, is this observational study or design experiment? Design experiment if we as researcher did something to the object of our survey. Now, this is not the case. We only observe. So this researcher actually observed people who are arriving and departing, who were arriving and departing from these two different airports. Okay, so this is observational. Okay, now then part B, explain why is it reasonable to use t-test. Why do we use test statistic t? Why do we use test statistic t? Well, because we are observing, we are doing hypothesis testing of two samples, two independent samples. Okay, two independent sample with unknown. Population standard deviations. Okay, while the sample size are greater than 30. Okay, basically there are two parts. First, sigma 1, sigma 2 are unknown. Okay, and either the underlying population, the X1, X2, the underlying population are normally distributed, which they don't say here, or the sample size are at least 30. Okay, basically it needs to satisfy central limit theorem hypothesis. Okay, the assumption of central limit theorem that the underlying distribution is at least normal or the sample size at least 30 has to be satisfied. Now, if sigma 1, sigma 2, population standard deviation from the population they are taken from are known, then we will use Z. We will not use T. Okay. Now, let's continue. And step part C, do individuals walk at different speed depending on whether they are departing or arriving. Now use alpha equals to 0.05. So we basically need to perform hypothesis test. Claim. Now you rephrase that question. Do individuals walk at different speed depending on whether they are departing or arriving? Now rephrase that into a statement. Okay, rephrase that into a statement. A statement, of course, then that's a claim, right? Then individuals walk at different speeds depending on whether they are departing or arriving. Step 2, hypothesis. Null hypothesis mu departure equals to mu arrival, right? Okay. Because the claim is they are different, right? Mu departure not equals to mu arrival. Now, but we don't have constant on one side here, so we need to modify this to be null hypothesis mu departure minus mu arrival equals to 0. Alternate hypothesis mu departure minus mu arrival not equals to 0. Okay. Now the claim is with the alternate hypothesis and it is a two-tailed test. Okay, now then step 3. Let me continue here. Step 3. What is the test statistic? Will be t equals to x bar 1 minus x bar 2. X bar departure 260 minus x bar arrival 269 minus mu d minus mu a, that's minus 0. Okay, even though we know it will subtract by 0 there, okay, because this guy always come from here, right? Okay, but you still need to write it down though. Okay, you still need to write it down. Now then, divided by the square root of sample variance of the first group over sample size plus the sample variance of the second group over the sample size. Okay. Now then we use our calculator. 260 minus 269, that's the numerator divided by square root of 53 squared over 35 plus 34 squared over 35. I get negative 0.84558. You know what? Let me show you how to use your calculator just to make sure. You need to know how to use this. You need to know how to do this. Because I did have that will be the silliest case though. Like you know what to do, but you don't know how to use your calculator. Okay, let's see. So 260 minus 269. So that's the numerator divided by, okay, the square root of 53 squared over 35 plus 34 squared over 35. Boom. Okay, that's how we compute that. Now that's the test statistic. Now let's go on. Let's go on. And then step 4. What happened? I cannot go down. Step 4. Then p-value. We have negative 8.4558, 0.84558. We need to find the area of the tail, but then we need to double it because it's two-tail case. So the p-value is 2 times TCDF negative E99 negative 0.84558, degree of freedom 34. Now remember, degree of freedom, if this is the smaller, the degree of freedom we will use is the smaller of those two degree of freedom. Now they happen to have the same sample size, right? So the degree of freedom will be 34 for each. Okay, will be 34 for each. Then we will use degree of freedom 34. Now use your calculator again. This TCDF, lower bound negative E99, and then upper bound is negative 0.84558, degree of freedom 34. We get 0.20185. 2 times 0.20185 and then multiplied by 2, 0.4070, huh? 0.40370, 0.40370. That's the p-value. Now then, informal conclusion. Because the p-value is greater than alpha, then we fail to reject null hypothesis. Fail to reject null hypothesis, then the conclusion will be there is no sufficient evidence, right? So conclusion, I think the alpha is 5%. So at 5% significance level, there is insufficient evidence to support the claim that individuals walk at different speeds depending on whether they are departing, or arriving. Let me check if my wording is correct. Yeah. Okay, that's the conclusion we get. Let me put some lines here to show that that's the cutoff from the next question. Okay, for extra points, what is the test critical value? Critical values. It's two-tailed, so you must have two critical values, right? Okay, it's the T critical. 5% divided into two tails, so each of them 25%. I'm sorry, 2.5%. So T critical will be plus minus inverse T. This is 95% here, right? So inverse T, the area to the left is 97.5%. Degree of freedom, 34. Now don't forget the plus minus. Okay, don't forget the plus minus. That's inverse T, area to the left, 0.975. Degree of freedom, 34. 2.03224. 2.03224. Now our test statistic is located slightly to the left of the peak. This is negative 0.8 something, right? While the critical value is plus minus 2 something. Okay, so the test statistic is not on the tail region. Therefore, we fail to reject null hypothesis. Next, let's check our numbers, especially for step 3 and step 4. Okay, we'll check our numbers with for step 3 and step 4. We go to stats, test, to sample t-test. Oh, I didn't show you this last time, huh? So we okay. So to do the calculator, for the calculator to confirm, right? You go to stat and then test, and then you go to sample t-test. We will use to sample z-test if the population standard deviations are known. Let me go back, stats, tests. Okay, number 3, you have to sample z-test. You use that if population standard deviations from those 2 samples are known. Okay, now we will use to sample t-test if the population standard deviation are not known and the sample size are greater than 30. Okay, so let's go back here. I need these informations. So let's say our first group is departure. Our second group is arrival. Now x1 bar is 260. Sample standard deviation is 53. Sample size 35. The mean speed for the arrival is 269. Okay, sample standard deviation 34 and sample size 35. Okay, we are testing against two tail. And is it pull? No, not pull. Okay, not pull. And then calculate. Let me put it here. So you see that our test statistic is this, and our p-value is this. Now, our p-value is slightly different because they use different degree of freedom. Okay, but Thomas, why their degree of freedom is different? Let me remind you that the degree of freedom that we use supposed to be computed using a strange formula like the one I showed you last time, right before the end of the class. So 11.3a, you see, we have this in our textbook. This is the formula for degree of freedom. It's way too complicated. It's way too complicated for us to do it by hand. Now, our calculator get this number, 57.9 something, because they use this formula. They use this formula. Okay, but we will not use this formula. We will not use this formula in our class. Okay, we will play safe, and when we say we play safe, conservative, then the degree of freedom we use will be the smaller number of two populations or of two samples. Okay, degree of freedoms from two samples, you use the smaller one. Okay, so let me mark that the degree of freedom they use is different from our degree of freedom. Okay, it's different. Okay, but you see that we still come up with the same conclusion. You know, the p-value that we have, the p-value they have, it's off by the third decimal place. Okay, we still come up with the same conclusion either way, in which we fail to reject null hypothesis. Okay, let's go on with number 12. This question is slightly more difficult because they don't arrange that for us. Okay, government waste. In a Gallup poll of 513 national adults aged 18 years or older who consider themselves to be Republican, so this is the Republican group. Okay, the sample size, let me call that the first group, and one is 513. They were asked, for every tax dollar that goes to the federal government in Washington, D.C., how many cents of each dollar would you say are wasted? Now, the mean wasted were found to be 54. So X1 bar is 54 cents with standard deviations 12.9. Now, the same question was asked to 513 national adults aged 18 years or older who consider themselves to be Democrat. So what you need to do first is arrange the informations, okay? N is 513, okay? And the mean wasted is 41 cents and sample standard deviation 2.6. Okay, now, oh, there's no question here. Let me check. Where's the question? Give me a second. What number is that? Number 12, huh? Or 14? Number 12. So, the question actually is construct 95% confidence interval for the mean difference. What we will do instead, we will do hypothesis testing on 5%. Okay, hypothesis testing at 5%. So we'll test at 5% significance level if Republican and Democrat national adults say have different say on how many cents of each dollar wasted. Okay, let's say that is the question. That's what they want us to do. I will start with question step 1, the claim. The claim: Republicans and Democrat national adults have different say on how many cents of each dollar wasted. Second hypothesis. So you may say that they have different say for now based on this sample, right? Okay, but the thing is, if we really check statistically, are they really different? So the mean for Republican is equal to the mean for Democrat. The mean for Republican is not equal to the mean for Democrat. Okay, now according to the wording of the claim, which I made up myself. Okay, I try to follow what the confidence interval say, but you can word it differently, but then you will see the hypothesis will come up to be the same. Okay, as long as you follow the different say, right? Okay, different means it's two-tailed. Okay, that will be claim here, and it is two-tailed again. It's two-tailed again. Oh, I don't have constant on the other side, so I have to modify that, which means now we are dealing with null hypothesis mu Republican minus mu Democrat equals to 0. Even though they say different things, but when you compute statistically, are they just the same, or they are actually significantly different? Okay, now step 3, test statistic. The sample size is actually very big though, it's 500 something. So T equals to 54 minus 41, right? You see here? Okay, see here? Minus mu R minus mu D, which is 0, over square root of 2.9 squared over 513 plus 2.6 squared over 513. Now we use our calculator. 54 minus 41. That's 13 divided by the square root of 2.9 squared over 513 plus 2.6 squared over 513. Wow, that's a very big difference, 75 something. 75.5 I mean, I myself surprised. Basically, 59782. 59782. Step 2, how about the p-value? Remember, I said that if the t-score or the c-score is more than 10, to the right of 10, or to the left of -10, then the area of the tail is practically 0. You know, so the area here will be practically 0, even if later on I multiplied by 2 due to a two-tailed test. Okay, but let's see. Okay, p-value, that would be 2 times TCDF 75.59782 to E99, degree of freedom 512. Okay, so I go to TCDF. Okay, the lower bound is our previous answer. Let me use that one. Okay, the upper bound is E99, degree freedom 512. That's basically 0. Okay, so this is 2 times 0 equals to 0. So step 5, informal conclusion. Reject null hypothesis, which means we will the evidence, the sample actually support the alternate hypothesis, which is the claim. Okay, conclusion. At 5% significance level, there is sufficient evidence to support the claim that copy paste whatever you have in the claim. Republican and Democrat national adults have different say on how many cents of each dollar wasted. Okay, that's for 11.3b. Now, some technical issue. Why we do what we do here? Okay, because of the following. Suppose we have a population called that X1 that is normally distributed with mean mu1 with variance sigma 1 square. And we have population X2 with mean mu2 and variance sigma 2 square. Now, what happens if we add or subtract these two populations? How will these, the sum or the difference, be distributed? And it will still be normally distributed with the mean mu1 plus mu2 minus if we subtract. However, the variance will be sigma 1 squared plus, and in case of minus, it is also plus sigma 2 squared. Now that's what happened at that time. Okay, now what happened with sample means? Well, okay, suppose you have x1 that is normally distributed with mean mu1 and variance sigma 1 squared. And then you do sampling of size n1. So x bar 1 with size n1. That will be normally distributed with the same mean. That's central limit theorem. Okay, and the variance will be sigma 1 squared over n1. Now for x2, if it is normally distributed with mean mu2 sigma 2 squared, then the sampling distribution x bar 2 with sample size n2 will also be normally distributed with mean mu2, but the variance will be sigma 2 squared over n2. Now, what happened if then we want to see how the sample means interact? Now then, according to what we see up here, basically, if you have two populations that are normally distributed, then what happened to the sum or difference? And it will also be normally distributed. The mean will be added or subtracted, depends on what you do. Okay, yet the variance will be, you add them. Even when that was subtracting, you still add them. Now that's why the denominator of our test statistic, looks like this. Okay, because according to central limit theorem, okay, we have this situation. The sum of sampling distributions or the difference of sampling distributions will be normally distributed, whose means depends on you add or subtract the means, yet the variance will be the sum of the variance of the sampling distribution. Okay, that's why on the top right, you subtract by mu1 minus mu2. See, let me write down the formula again for the test statistic. The test statistic is supposed to be z equals to x1 bar minus x2 bar minus mu1 minus mu2, right? Over square root of sigma 1 squared over n1 plus sigma 2 squared over n2. That's what's supposed to be. But because we don't have the population standard deviations for each one of them, then this evolved to t. And the denominator here, we substitute the sigma 1 squared but S1 by S1 squared. And sample standard deviation of the second group, actually sample variance of the second group over N2. That's what happened. Okay, that's the foundation. So this guy here is from here. Okay, this guy is here, right now. So this is still the same. Okay, but because we don't have the population standard deviations, then we replace by sample standard deviations. And therefore, C becomes T. Okay, now these are the theoretical foundation, technical foundations. what happened, Thomas? It's too hard for me. I read that. I don't understand your notation. Then don't worry. Okay, I will never ask this kind of question anyway. Hold on. Okay, let me use theoretical foundation. Okay, basically what happened here is we apply central limit theorem. So maybe the underlying population are not normally distributed, but as long as the sample size is more than 30, then we can apply central limit theorem for each sampling distribution. Now, when we subtract those sampling distributions, they will still be normal. Okay, they will still be normal. Okay, that's for 11.3b. Let's go on to 11.2. Now, what is 11.2? 11.2 is hypothesis testing on two population means dependent case. Or we also known as match pair. Basically, what will happen is the following. Okay, we will have the same sample subject. Okay, same sample subjects that give us two numbers. Let's say, for example, we are testing if a certain diet program, a weight loss program, weight management program, a certain SAT course, a certain training actually improve the way a student actually perform in SAT, for example. So they will have, for each student, they will get the score before and after treatment. Okay, so what happened is you have the same subject, let's say student number 1 have the score before and after. Student number 2 has the score before and after. Okay, so when I say the same subject, so it's the same people who take the test, the test before the course or after the course. Okay, or for weight management, for example, before they join that weight management program, what's the weight, and then after a couple months, let's say, what's the weight. Okay. Now the way we will do this is we will later on find the difference. So even though we have, let's say, n subjects, so we will have 2 times n numbers, right? But we will end up with only n differences. We'll have the first difference, second difference, all the way to dn. Okay. Difference number for subject number n. Now then, from there, we will find d bar. And sample standard deviations for the differences. We will perform hypothesis tests on these. We call that mu d. Okay, the d should be subscript. Okay, let's see the pattern first. Let's see the template. The template for the procedure. Step 1, no difference. Step 2, hypothesis. The null hypothesis will be mu1 is equal to, less than, equal to, greater, equals to mu2. But because we need a constant, then we subtract both sides by mu2. That's how we get the constant. So you see that so far it's the same to what we have in the case of independent case, okay? But we need to go on further because this is a match pair. This is a match pair. So instead of mu1, mu2, we will actually observe mu of the difference. The average of the differences. So instead of seeing them as two separate samples, once we subtract them, we are dealing with only one samples of the differences. After all, you can match them. Okay, now then, what happened to test statistic? We basically perform hypothesis testing on the differences. So we will get D bar. Instead of X bars, we will be the sample differences, the mean of the differences from the sample minus mu D. In this case, it will be 0, right? Okay, over the standard deviations of the differences over square root of n. Now, notice that this formula actually mimics what we learned in chapter 10. T equals to x bar minus mu over s over square root of n. But now the data are the differences. Now, the rest for step 4, 5, 6 are basically the same. Step 4, step 5, step 6, basically the same to what we did before. Okay. Now, the nice thing about giving you the template is this. Once we master the template, which I assume you already have, once you master a template, then everything after this, all the variations, only make us do substitution on step 2 or step 3 or step 4. Okay. Now, of course, I believe I already have some explanation from my lecture video with some examples there. Now, what I do here, I only review again of what we will do. Okay, now let's do problems. Start from number 3. Now we have observations from seven subjects. Okay, let's say this is the observation under condition X, and this is the observation of the same subjects under condition Y. Let's say X and Y's are the number of inhale and exhales somebody's doing for X1 before that person fall asleep. Number of inhale and exhale before that person fall to sleep. And Y's are the number of inhale, exhales right after that person awake per minute. Okay, and we want to see, is there any difference? Now, part A here, ABC actually help us with what we need to do. So part A, find the difference. So the DI, the difference here. Okay, xi minus yi. So x1 minus y1, that will be negative 0.5, right? If you subtract this. Maybe I do it here, negative 0.5. This is 1.0. This is negative 3.3, negative 3.7. This is 0.5, negative 2.4, negative 2.9. Okay, now I copy that here so that we can see better. 1.0, negative 3.3, negative 3.7, 0.5, negative 2.4, negative 2.9. That's our D's. Okay, and then part B, we will find the D bar and SD. Okay, so n equals to 7. What is the sum of these? So you add these numbers here, okay, and we'll find the sum of D squared. After we get these three numbers later on, I will show you how to use calculator. So basically what we need? We need these three numbers, and then from there we will find D bar, which is what we have from here divided by 7, divided by n, right? And then the variance of the differences equals to 7 times the sum of D squared minus the sum of D being squared. Remember that formula? Over 7 times 6. Okay. Now, let me teach you how to use calculator to get this number a lot faster. So we basically do nearly no computation. I go to stats. Let me see. Okay, my list one need to be cleaned up. So stats, clear list, list one. Okay, it's clean. Now, this is what I will do. Okay. I will input observation X to list one. But you need to do it in exactly the same order. Okay, 7.6, that's X1. X2 is also 7.6. X3 7.4. X4 5.7. X5 8.3. X6 6.6. X7 5.6. Done. Okay, now then list 2. Make sure you do it in the same order. Okay, Y1 is 8.1. Y2 is 6.6. Y3 is 10.7. Y4 is 9.4. Y5 is 7.8. Y6 is 9.0. And then Y7 is 8.5. Okay, I enter all the numbers right now. Go on to L3. But instead of inserting or inputting the difference one by one, what I will do is I tell the calculator the formula I will use for L3. So you go up. You see the highlight right now here, right? Okay, I go up. You see the highlight now is L3. Okay, now, so once you are there, then you will put in L1, which is associated to data X, minus L2, which is associated to data Y. Okay, so L1, do you see that? Minus L2. Boom. Now they will fill it up yourself for you. Okay, now you see that these numbers, negative 0.5, 1.0, negative 3.3, negative 3.7, 0.5, negative 2.4, negative 2.9 are the same in the same order, in fact. Now, we will now compute or calculate the one var stats from there, from that L3. Let me screenshot that. Okay, so the sum of the d's, the sum of the d's, that sum of x, that's negative 11.3. Sum of d squared is 40.25. Okay, so this will be negative 11.3 over 7. That will give us negative 1.61429. Okay, the sample variance, that's 7 times 40.25 minus negative 11.3, don't forget parentheses, divided by 7 times 6. Okay, I will use calculator to compute that. 7 times 40.25 minus 11.3 squared. Okay, even though that's negative, when we square it becomes positive anywhere. That will give us the number on the numerator divided by 42, the number on the denominator. That's 3.66810. That's 3.66810. Now apply the square root here. That's 1.91523. Which is the same number to this. Okay, so this way you show me the computation that I want to see. You give me what I want to see, but at the same time, you use your calculator to help you computing it. Okay, now that's for part B. Now let's see part C. Part C, test if mu d less than 0. Step 1, there's no claim. Step 2, the hypothesis. That's alternate hypothesis, mu d is less than 0. Null hypothesis, mu d is greater or equals to 0. Or you also say equals to 0 is okay. Now the claim is here. No, they just basically, no, there's no claim. But we know it's left tail. That's what I want to write. That's left tail. Now, step 3, test statistic. T equals to the D bar, negative 1.61429 minus mu D, 0, over sample standard deviation 1.91523 over square root of 7. That's negative 1.61429 divided by the square root of 1.91523 divided by, oops, I'm sorry, that thing is not in square root. Divided by parenthesis 1.91523 divided by the square root. I almost typed it wrong, of 7. That's negative 2.23002. Negative 2.23002. That's the test statistic. How about the p-value? That's a left tail, and it's a t-test. So this is negative 2.23002. The p-value is TCDF, negative E99, negative 2.23002, degree of freedom 6. Negative E99, the upper bound is negative 2.23002, degree of freedom is 6. Negative, I'm sorry, 0.03363. 0.03363. Okay, the alpha is what? Let's see, what's the alpha? 5%. Okay, so reject null hypothesis. Informal conclusion. Reject null hypothesis. But we cannot get conclusion because there's no claim. How about the critical value? The alpha is 5% on the left tail. So T critical is inverse T, the area to the left 0.05, degree freedom 6. Inverse T, area to the left 0.05, degree freedom 6. Negative 1.94318. Negative 1.94318. So you see our test statistic is actually on the tail. This is negative 2.2, right? While the critical value is negative 1.9. Okay, that's why we reject null hypothesis. Now, however, I want to show you something more important here. Can we use a calculator to confirm our result? Yes, actually, like what I said earlier, you just apply our hypothesis testing on the differences, right? So you go to stats, tests, t-test. T-test. Yes, we have a pair, right? But we match them. So we actually just do t-test. We can use the t-test and then you plug in the stats here. Let me show you. The mu naught is 0. The x bar is, oh, they already do it for us. Okay, so x bar is this, sx is this, and then we are doing left tail, right? This is what we get. So you see our test statistic is this, our p-value is this. Confirm, right? Okay, confirm. Now, we can actually do the following too. You go to stats, and then you test, t-test. Now, remember that we already have the data actually, right? We actually have the data from list number 3. So you go to data instead of stats, data. Now, then they will ask you, what is your mu0? That's 0, right? That's your mu d. How about the list? You use list 3, not list 1. Not list 1. List 1 is the data x. List 2 is data y. List 3 are the differences. Okay? And then we do a left tail test, calculate. Now you see we get exactly the same thing. You see that? Okay, but this result does not give you what is the sum of d and sum of d squared. Okay, to get the sum of d squared, you go to stats, one var stats, apply that to list 3. Okay, so that's the one we have here. That's the one we have here. I hope now you know why your calculator, if you buy the handheld, the actual calculator, why it costs so much. It's because of this. Okay, they program a lot of things in there. Now, let's do number 7. Let me move this down a bit. Even more. Let's do number 7. The following data represent the muzzle velocity in feet per second of rounds fired from 15.5. No, that's 155 millimeters gun. For each round, 2 measurements of velocity were recorded using 2 different measuring devices with the following data obtained. So we have these. Now, why are these part A? Why are these match pairs? Well, because you have 12 observations, right? Observations on 12 subjects. If each subject, you observe that using 2 different devices. So you can pair them. Like subject number 1, using device A, you get this. Using device B, you get this. Okay, and so on and so forth. Now, the question part B, let me go to B right away. Is there difference in measurement of the muzzle velocity between device A and device B at alpha equals to 0.01? Okay, so let's put the claim. There is a difference in the measurement of the muzzle velocity between device A and device B. That's our step 1. Step 2, hypothesis. Null hypothesis, alternate hypothesis. So mu A is not equals to mu B, right? Because difference, they are different. Mu A equal to mu B. But we don't have constant on one side, so we need to subtract. Mu A minus mu B equals to 0. For the null hypothesis, alternate hypothesis, mu A minus mu B not equals to 0. Now, because they are match pair, then we can condense that even further. Instead of mu A minus mu B, we call that mu of the differences. Okay, now step 3, test statistic. We need to find the t. We need to find the t where on the top we have d bar minus mu d over s d divided by square root of n. Now we know n is 12. We know mu d is 0, but we still need to find out what the sample mean of the differences and the sample standard deviations of the differences. Okay, now let's do that. So we step back. Okay, well, we have n equals to 12. That's easy. We need to find the sum of d's and the sum of d squared. Okay, then from there, we will be able to find d bar and the sample variance of the differences. And after that, we get sample standard deviations of the differences. Okay, we'll get these numbers. How we get that? I will be cheating. I use calculator. I plug in numbers. There are 12 numbers I need to put in. Oops, not this one. There will be 12 numbers to put in. Times 2, so 24. Okay, I go to stats. I remember that we use L1, L2, L3 up, right? So let's clean them up first. So clear list. We need to clear list 1, comma, list 2, comma, list 3. Okay, then go back, edit list 1, observation A's. 793.8. Observation, the second observation from A is 793.1. The third, 792.4. The fourth, 794. The fifth, 791.2. The sixth, 792.4. The seventh, 791.7. The eighth, 792.3. The ninth, 789.6. 794.4. 790.9. and 793.5. So those are the data from observation A. Let's go to observation B. You need to be patient though. You already use calculator. All you need to do is actually know how to input the data. I'm sorry, that's 793.2. And of course, how to use your calculator. This is data number 6 from observation B. Data number 7, 791.6, 792.4, 788.5, 794.7, right? That's data number 10, right? 791.3 and 793.5. Now then L3, go to the top again. Okay, you need to shift to the heading, to the header. Okay, and then we do L1 observation A minus L2 observation B. So the L3 will give you the differences. Okay, now you go to stats, calculate, one var stats, L3. So let me put my result from calculator here. So my sum of D is 1.2. My sum of D squared is 2.76. See, nice, they computed for us, right? Now then, D bar, basically 1.2 over 12. You can see clearly this is 0.1 and it matched with this, right? Okay, now how about the variance of the differences? That will be 12 times 2.76 minus 1.2 squared over 12 times 11. Let me calculate that. 12 times 2.76 minus 1.2 squared divided by parentheses 12 times 11. That's 0.24. Now then standard deviations for the differences is square root of 0.24 0.489898. 0.489898. You see that it matched with what they tell us here. Okay, so what I did actually, I key in numbers and then use those numbers to help me with my computation. Okay, and to confirm. Okay, now I will continue. So my D bar is 0.1. My standard deviations of the differences is 0.48990. If I round it to 5 decimal places, so T equals to 0.1, it's on the numerator, divided by parentheses 0.48990 divided by square root of 12. That's 0.70710. 0.70710. You know what? Let's do hypothesis test right away. So the stat and then test and then t-test. We use data. Okay, the mu 0, L3. We did left tail. Is it right? No, two tail. We do two tail. Let me screenshot this. So basically, I'm trying to teach you how to get your number fast. Okay. So you see my T confirms, right? That's because the error on the fifth decimal place is supposed to be 0.70711 in this case. Now, the reason is because, remember, I rounded here, right? So if you use 90 here, then it will be this. If you use 89, okay, 898, then it will be 1 here. Now then step 4. How about the p-value? That's a two-tail. This is 0.70710. And I will double it later on because it's two-tail. Okay, so my p-value is 2 times TCDF 0.70710 E 99 degree of freedom 11. Now, according to what we have on our calculator, the p-value later on is supposed to be 0.49421, or a little bit off from there. Okay, but let's see. This is 2 times, use our calculator again, TCDF, lower bound, 0.70710, upper bound E99, let me just use 100, degree of freedom 11. I get 0.247106. 0.247106 multiplied by 2. Do you see that? 0.49421 if I will round to 5 decimal places. Okay, now our number here is slightly off from there, but when we round to 5 decimal places, it's the same anyway in this case. The numbers is too close. The number is too close. If you didn't round anything here, then the number you have will be pretty much the same. Okay, even right now it's pretty much the same. Now, the p-value is so big. The p-value is very, very big. So the informal conclusion failed to reject null hypothesis, especially because the alpha is, they want us to use 1%, right? The informal conclusion failed to reject null hypothesis. Okay, and therefore, conclusion, at 1% significance level, there is insufficient evidence to support the claim that there is difference in the measurement of the muscle velocity between device A and device B. So it doesn't say there is no difference. It doesn't say that there is no difference. Okay, it's just say that we don't have enough evidence to support that claim. Okay, from the samples that we see that there are differences, but the differences are not significant. Yeah, the difference is not significant. Okay, the p-value is almost 50%. Okay, now notice that at the same time, I already give you the calculated result, right? Now, if you want to get extra points, then of course you do the critical value. This is 2 tail, 1% divided by 2, that's 0.005 for each tail. So the critical value will be plus minus inverse t, area to the left 0.995, degree of freedom 11. $3.10581 plus minus 3.1080581. While our t test statistic is actually 0.7. Okay, that's why we failed to reject null hypothesis. Okay, now I will take a break. You should take a break also. And then after you come back, so we will take 10 minutes break and then another 10 minutes for you to, so 10 minutes break. And then 10 minutes, I want you to key in data to L1, L2, and get L3, calculate to find N. So using our one var stats, right? Okay, calculate N, the sum of D, the sum of D squared, and just go ahead with the D bar, just write it down from there, and standard deviation of the differences. Okay, I want you to get this. Then after that, we will do it together. After that, we'll do together the hypothesis testing. Okay, the hypothesis test says, so claim. So this is the daily rental for compact car charged by 2 car rental companies, Thrifty and Hertz, in 10 locations. Test whether Thrifty is less expensive than Hertz. Okay, but we'll do it together later on. Okay, so 20 minutes from now, we come back at 5:55. Okay, let's continue. Let me move this up. Erase this. Then use my calculator. Key in data. I will need to clean up list 1, 2, 3. So stats, clear list, list 1, list 2, list 3. Okay, so let's start. The top left, 21.81, 29.89, 17.9, 27.98, 24.61, 21.96, 20.90, 37.75, 33.81, 33.49. So that's from the first column. Let's go to the second column. It has to be in the same order. Okay, exactly, because it's paired, right? It's match paired. 37.99, 19.99, 35.99, 25.6, 22.99, 19.99, 36.99, 26.99, 30.99. Done. Okay, now then go to list 3, go to the header, list 1 minus list 2. Boom. Now the stats, 1 var stats, list 3, calculate. Let me put it here. Okay, so sum of these is negative 6.41. Sum of d squared is 198.2997. D bar will be negative 0.641. Standard deviation will be 4.64508. Okay, now step 2, hypothesis. Thrifty is less expensive, so H1 mu T is less than mu H, right? But because it's match paired, then we modified this to be mu D greater equals to 0, mu D less than 0. Okay, step 3, test statistic. T equals to D bar minus 0. D bar is negative 0.641 minus 0 over 4.64508 over square root of 10. Okay, n equals to 10. Okay, which is equal to, just use your calculator. I will just use my calculator. Okay, stats, t-test. Okay, using stats here. Mu D is 0. X bar is that. And this one, let me change it. This is the one not rounded though. Oh, that's okay. I'll just leave like that. But then less than 0. Calculate. This way, I can get the test statistic and later on p-value faster. Okay, basically, I ask the calculator to compute it for us. So this will be the test statistic will be C negative 0.43638. And then step 4, p-value. That's a left tail, negative 0.43638. P-value, you still need to write your calculator notation though. This is TCDF, negative E99, negative 0.43638, degree of freedom 9. Okay, but according to our calculator, that's 0.33642. Okay, you can compute using your calculator to confirm that's the number, but I believe that is. Okay, now step 5, because the alpha, by the way, is 10%. Okay, so the informal conclusion failed to reject null hypothesis. And conclusion at 10% significance level, there is insufficient evidence to support the claim that thrifty is less expensive than Hertz. For 4B, the critical value left tail 10%. Inverse T, area to the left 0.1, degree freedom 9. Okay, so distribution inverse T, area to the left 0.1, degree of freedom 9, negative 1.38303. Negative 1.38303. So that's the test statistic. I'm sorry, critical value. The test statistic is only negative 0.4 something. So it is failed to reject null hypothesis. Okay. So what is new actually here is just, I just need you to know how to find the differences and compute the D bar and the mean of the differences and standard deviation of the differences. And those are actually doable using calculator. Okay, even if I need you to show me, the differences here, okay, even if I need you to show me the differences there, you still can use calculator. Okay, you see, what you have here is the differences. Okay, 2.82, negative 8.1, negative 2.09, so on and so forth. Okay, so even if I need you to show me the work here, you can actually use your calculator, okay, to do that. Now, I need to make you be aware that in real life, you don't use TI-84 though. Okay, so how will you do this if you use Excel? Well, just plug in numbers. Okay, and then you need to know how to use Excel though. So the difference here will be basically equals to this cell, call that A2 minus B2. This is A2, this is B2, let's say. Okay, and then you copy paste that here. Now down here you get the sum. And then you extend that again, you get D squared. Right? And then you square them. And then the sum down here will be the sum of D squared. So on and so forth. Okay. But yes, that's if you know how to use Excel. Now, if you don't know how to use Excel, it's basically you cannot perform statistical work without TI-84. Okay, so learn Excel as your senior in college and university, somebody who already went to university. Excel is the second most important software, of course, other than email, Canvas, right? Excel is the second most important software that you need to know how to use, at least at early, like early, not you don't need to be super expert, like you know every secret. No, I don't know all the secrets. I'm still learning, okay? But what I learned so far, what I know so far is enough for me to perform statistical analysis using Excel. Okay, now that's for 11.2. That's for hypothesis testing on two population means, dependent case or matched pair case. Okay, how about 11.1? 11.1 is hypothesis testing on two population proportion. It's P1 minus P2. Okay, again, the template, step 1, 2, 3, 4, 5, 6. Template. The difference will be in step 2. We will have null hypothesis, alternate hypothesis, P1 is not equal to, less than or greater than P2. Okay, now null hypothesis, you adjust that accordingly. But then because we don't have constant on the other side, we adjust or, yeah, we adjust our null and alternate hypothesis becomes P1 minus P2 not equals to, less than, greater than 0. Okay, and step 3. Now this is complicated. Test statistic. Just like before, when we are testing proportion, we always use C-score. Okay, and the test statistic is P1 hat minus P2 hat minus P1 minus P2, which will be 0 over square root of, now this one is nasty, P bar Q bar over N1 plus P bar Q bar over N2. That's the test statistic. Now the rest are the same. Now, what is P1 hat? P1 hat is the number of successes from the first sample over the sample size. P2 hat is the proportion of successes in the second sample. Now, P bar is called pool proportion. Pool, like you put them together. Okay, basically the total samples you have is N1 and N2 added, right? And the number of successes put together will be X1 plus X2. It's like the word pool here, think of that as the carpool pool. You pull them together. Okay, let's say, pictorially, suppose you have group 1, right? Okay, this is the number of successes over the number of the total sample size. Now in group 2, you have this. And let's say this is the number of successes. Now, when we pool means we basically combine these two people here, these two groups here into one class, into one pool. Let's say, for example, let's say X1 is the number of females in the class of N1. So let's say there are 19 females over 30 students in the first class. And the second class, you have 21 females out of, let's say, 35 students. Okay, now when we say we pool them, basically we put them together into one pool. Okay, so how many females we have in total? That's 30 plus 35. I'm sorry, how many students we have in total and how many females we have in total? That's 19 plus 21, like that. Okay, this is P1 hat, 19 over 30. P2 hat will be 21 over 35. Now P bar, however, is 40 over 65, like that. Okay, if you pull them together, just imagine carpool. Okay, just imagine carpool. You pull them together. Now, the painful part is really key in this number here later on. Very painful, very painful. Okay, so be very patient. Okay, the good news is step 1, 4, 5, 6 are just the same. Okay, with the time I have, I think I can do at least 2 problems. So I will do one without the one without claim and another one with claim. Okay, let's do number 9. Okay, test whether P1 greater than P2. Okay, the sample data, let's organize that. X1 is 368 and 1 is 541. X2 is 351 and 2 is 593. So P1 hat is 368 over 541. I will use my calculator. 368 over 541. That's 0.68022. And P2 hat will be 351 over 593. Actually, if you get used to my notation since the beginning, it's actually quite easy to understand what is P1 hat, P2 hat, how to compute them. But of course, you need to get used to it. Okay. At this point, it's kind of really hard if you still need to say, oh, you know what is P2 hat again? You know, as if you have never done P hat before. Okay, but we did this for the last 3 weeks, maybe even 4 weeks. Okay, start from confidence interval, right? Start from confidence interval, at least 3 weeks, maybe 4 weeks. Okay, so those students who don't get used to see my notation, which is actually not my notation, that's not fair. When you learn statistics, you need to learn to read notation and understand what they mean. Okay, otherwise it will be too heavy. Okay, now P bar will be 368 plus 351 over 541 plus 593. Okay, so on the top I have 719. Is it right? 368 plus 351, 719. At the bottom we get 1134. Okay, now then 719 over 1134 equals to 0.63404. Now you will see P bar always in between these two numbers, not the midpoint, not exactly in the middle, no, but this number for sure between these two numbers. Okay, for sure between those two numbers. So yeah, think of this as your setup. Okay, now then we can start the hypothesis test. Step 1, the claim is not given. That's none. Step 2, hypothesis. Null hypothesis, alternate hypothesis. P1 is greater than P2. So the null hypothesis, I get the complement. Okay, this is the claim here, right? This is the claim. No, I should not say that's the claim again. I don't have the claim, but I don't even know is it left tail or right tail until I have a constant on the other side. I'm sorry. I need to see, we cannot skip that step, right? So P1 minus P2 greater than 0. Oh, that's a right tail. P1 minus P2 less than equals to 0. Okay, step 3, test statistic. Z equals to P1 hat 0.68022 minus P2 hat 0.59191 minus 0 over square root of P bar 0.63404 times Q bar 0.36596 over N1. Let's compute what is Q bar here. Q bar is 1 minus P bar, 0.36596. Continue. Plus P bar Q bar over N2, 593. So I will copy paste 0.63404, 0.36596. Okay, now that is quite difficult to plug in. You need to really focus though when you use your calculator. Okay, let me show you. Am I at the right screen right now? Okay, good. Okay, so exit. Okay, so let me do the numerator first. The numerator will be 0.68022 minus 0.59191, close parenthesis. That's for the numerator, right? Divided by the square root of, now, this is the painful one, 0.63404 times 0.36596 over 541. That's for the first part here, for this one, Okay, now plus 0.63404 times 0.36596 over 593. 3.08357. Okay, and now then, how about the p-value? The p-value, let me give myself more space here. That's standard normal distribution. That's a right tail, 3.08357. So p-value is, it's standard normal, right? So there will be normal CDF 3.08357 E9901. So 3.08357 E99 0.00102. 0.00102. That's a very small p-value. Okay. They tell us to use alpha 0.05. With alpha 0.05, my p-value is even smaller. So informal conclusion, reject null hypothesis. The conclusion, however, is none because we don't even have a claim, right? Now, how about the critical value, 4b? Critical value. You know what? Let me shift this down. It's right tail. And we want 5%. See, critical is inverse norm. The area to the left, 0.9501. I believe that's 1.64485. Let me check. That's right. Now, I think what is more crucial here is, do we have a calculator to help us with this? The answer is yes. Okay, so please be smart. I still need you to give me that step 1, 2, 3, 4, 5, 6. Okay, but step 3, which is the most difficult part, after you write down the formula, okay, then this number here should be from your calculator. Okay, you can get that from your calculator. So let me show you. Okay, we go to, let me write it down first. Calculator. You go to stat, test, to proportion Z test. Proportion always C test. Proportion always C test. Okay, so go to stats, test, to proportion C test. Done. Now then you need to plug in your x1 N1, X2, N2, so on and so forth. Okay, which I will do right now. X1 368, N1 541, X2 351, N2 593. And we are testing right tail. Calculate, boom. So you see that calculator helps you speed up the computation a lot. Okay, you see my test statistic is very close, right? I'm correct to 3 decimal places. Now, why they are different, Thomas? Because when you use these numbers here, they are already included, already have rounding error. Okay, it already has rounding error. Now, how about the p-value? You see, this is our p-value. This is calculator p-value. Right? In fact, the nice thing is they give us P1 hat, P1 hat, P2 hat, and P bar. Right? Okay, so it's basically if you know how to use your calculator, especially this hypothesis testing part, for this one here, you can do this actually quite fast. Okay, you can do this quite fast. Now, let's try doing one problem, one word problem from the very beginning. Number 19. In October 1947, the Gallup organization surveyed 1,100 adult Americans and asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? So in 1947, organize your information. Okay, the sample size is 1100. And X1, the number of people abstain, totally abstain is 407. Now, in recent survey, with the same question for the same number of people, it's 1100, X2, 333 indicated that there were total abstainer. So the claim has the proportion of adult Americans who totally abstain from alcohol changed. So the claim, we need to make it into a statement, not a question though. The proportion of adult Americans who totally abstain from alcohol has changed. Oh, by the way, one of my favorite, very well-respected pastor back in Indonesia, he is currently 81 years old. Someone I very, very respect. I was told that in his life, he has not consumed any soda. Now, I don't know if this is true, but I have, like around 20 years ago, 20-something years ago, I have heard that from him himself at that time that he had never tried. He doesn't like soda, okay? And he never tried that. which was like, what? You never tried it, not even a sip. Okay, which is honestly is questionable. I like soda, but we never know. Okay, we never know. But I respect him a lot in the sense that he knows his stuff. He knows his stuff. This is a pastor, but he knows a lot about chemistry and physics. Okay, his son, now also a pastor, actually has a PhD in nuclear engineering from University of Connecticut. So, I mean, they are pastors, okay, but you think that they don't know stuff? No, his son is actually very, very, very smart. Okay, his son is the one who had 4 bachelors in math, physics, computer science, and philosophy. 4 degrees, 4 bachelor degrees in 4 years with 4.0 GPA. In 4 years. It's like we work so hard for 1 bachelor, right? And very likely is in more than 4 years, maybe 5 or even 6 years. He finished 4 in 4 years. And all while I was told that he at some point he actually worked part-time. Okay, so this guy is smart and dedicated and applied himself. I'm talking about his son. You know, so and his son is someone very how to say that, very quite strict on himself too, as you can see what he already achieved, right? Someone I respect. So I respect his dad and his mom. So this respected pastor I call, because not only for his preaching, his stand on a lot of issues and why he says so. Doesn't mean I agree with him all the time, but at least I understand why he has those kind of stand. Okay, but his children, all of them are successful, especially the son. Yes, it's like, wow, you can do that much, you know. And the fact that his son, even though with a PhD from nuclear engineering from University of Connecticut, you know, University of Connecticut is the place where they actually, as far as I know, I'm not really sure, but as I remember, that's the university where they get the baby, what you call that, the bomb that they construct for Hiroshima and Nagasaki. I'm not sure, but as I remember, that's the place. Okay, so he got his PhD there. He can easily get a good job in America, even if when he went back to Indonesia, a lot of Indonesian universities, as far as I know, actually asked him to be their professor. But he said no. He wanted to be, his calling is to be a pastor. Okay, well, anyway, this talk about alcohol, right? Which in my opinion, quite extreme. But I respect their view. The fact that they don't, like this family don't have soda, it's quite surprising, but see, they are all successful. Okay, if only soda make a difference between my children being good at school and not, I will tell my children not to drink soda, and I will not drink soda anymore for the rest of my life. Okay, if somebody can prove that to me. Okay, and we have one sample for now. Okay, let's come back here. So hypothesis, we have null hypothesis, alternate hypothesis. They want to say it's already changed, right? So P1 is not different, is different from P2. The null hypothesis, they are the same. Okay, null hypothesis, alternate hypothesis. I set one side to be 0, subtract both sides by P2. Okay, now then I will do the test statistic, but I don't have any numbers yet so far. Okay, I want to show you, like, if you want to focus on what you want to get, okay, then you will do this. You go to stats, test, tool proportion C test. Remember, I will just plug in numbers here. and we'll get all the numbers we need. 4, 7, and 1 is 1100, and x2 is 333, and 2 is 1100. Okay, and then we are testing two-tail. Okay, then calculate. Doom. Okay, I will use these results here and post it here. Now, of course, I will pretend then that I will compute the P1 hat, P2 hat, so on and so forth, right? So P1 hat will be 407 over 1100, which is equal to, then I cheat from my calculator. Okay, that's 0.37. Okay, P2 hat, that's 0.30273, right? I cheat from my calculator. Oh, hold on, I need to write down how I get that. And then P bar will be 407 minus 3 plus 333 over 1100 plus 1100. This is 740 over 2200, 0.33636. Is it okay? So at least I show the computation, but the final answer 0.37, 0.30273, and this guy I actually get them from calculator. Okay, now then, step 3, test statistic. I still write the numbers. C equals to P1 hat 0.37 minus P2 hat 0.30273 minus P1 minus P2, that's 0 over square root of, oh shoot, what is Q hat? Q hat is 1 minus 0.33636, 0.66364. So I will write it here, 0.33636 times 0.66364 over 1100. That's for N1 plus for N2, 0.33636 times 0.66364 over 1100. What is my C-score? Then you cheat from here. 3.33926. 3.33926 from here. But you still need to write this thing though. At least you pretend, right? Pretend that you compute that and benefit from our calculator. See, typing this into your calculator will take pretty much forever. Let's try it. Okay, and of course, if I use my calculator computing this manually, the number I get will be for sure is different from this. Why? Our calculator didn't round it, or maybe they rounded to 10 decimal places, while we rounded to 5 decimal places. So let's see, on the numerator, 0.37 minus 0.30273, that's the numerator, divided by the square root of 0.33636 times 0.66364 over 1100 plus the same thing, actually exactly the same thing, 3.33636 33914. If we actually compute this, that will be 3.33914. So you see we are off at the third decimal place because of that 5 decimal place rounding. Imagine if you only do 2 decimal places rounding, then your C-score will be off by quite a big number. Okay, now that's the test statistic. Maybe this is from calculator, from stat test to proportion C test, and this is computing. We actually compute this. Okay, so this is the result if we round to 5 decimal places since the beginning. This is the result if we round to 5 decimal places only at the end of our computation. So everything else is 10 decimal places. Now then, p-value. Hold on. This is two-tail. So 3.33926. We get the area here and then double it. Two times normal CDF, 3.33926 E99 01. That's 2 times something, but from my calculator earlier, the t-stats, we find out the p will be the 4th decimal place is 8. The 4th decimal place is 8. So this will be 0.00084. Let's confirm that using calculator. So this will be normal CDF 3.33926. That's 42 in the 4th decimal place, 0.00042. Then you multiply by 2. That's what you get. Okay, now suppose I use this number instead. Suppose I use that number instead. Okay, normal CDF 3.33914 E99. You see, we get the same thing, right? Okay, that will be 0.00042. When we round it to 5 decimal places, we get the same thing. So this is 0.00084. Alpha is 5%. So P, that's the P value. Then informal conclusion. Reject null hypothesis. Okay, so what's the conclusion? The proportion of adult Americans who totally abstain from alcohol has changed. Conclusion. At a 5% significance level, there is sufficient evidence to support the claim that the proportion of adult Americans who totally abstain from alcohol has changed. Okay, this is where I will stop. For the suggested homework, you go back to 11.3, choose maybe 2 problems from there. 11.2, choose 2 problems from there. 11.1, choose 2 problems from here. Okay, other than the one I did. And of course, make sure that you already watched the lecture video and you already go over this. Okay, make sure you do it with your own hand, not just see me doing that. Seeing somebody else doing that is different from you do it on your own. Okay, make sure that when you have the test, that is not the first time you apply what you learn. Okay, you learn something, but you need to apply that with your own hand, and make sure that's not what you do in the test. Okay, your test should not be the first time you write hypothesis testing. Okay, it's not supposed to be. Okay, I will stop here. And on Wednesday, we will start working on all tests, previous test 4. Hopefully, we have a chance to do one. Finish one full test. And this Friday, I will have my Friday class. Also have, I hope we can have another one set of test 4 being finished. Therefore, both of you will have 2 sets of test 4 to study from. That has the video. Okay, see you then.